Our next speaker is Martin Michelmeier, a previous Debian project leader, contributor to the Debian QA effort. He's recently finishing, or he's now finishing up research into release management in large free software projects, and today he's going to give a presentation on his research findings. Please welcome Martin.
Okay, thanks, Andrew. The research I've been doing about the last three and a half years is about quality issues in free and open source software projects. And specifically, I've been focusing on release management. I should say that that work has kindly been funded by Google in the last 2 years. I'm very happy about that. And I'm really happy to be here to now present the results of that work, which I think are really interesting for the community. I also have to apologize that my voice is a little bit strange because I've had a cold for a few days, and yesterday my voice got lost. So I'm sorry about that. Just looking at the agenda of that talk, first of all, I will briefly talk about the background of the research, where I come from and how I was looking at things. Then I will introduce the projects which I've studied during my research. As Andrew mentioned, I've been involved in Debian for a number of years, and Debian is known for its problems with release management, but I didn't focus specifically on Debian. I looked at a number of different projects, and believe me, many of them have problems with release management. So I will look at problems which those projects have had, and what kind of solutions they implemented for those problems. Specifically, what I have studied is a relatively new release mechanism known as time-based releases. In the past, usually you would release when a certain set of features has been achieved or implemented. But nowadays, a couple of projects, most prominent Gnome, are releasing according to time. So they don't have any specific features which determine whether a release is done, but they say we are going to make a release every 6 months. And that's their release strategy. And I think that's a very unique and very new approach. And I've decided to study that specifically because there's loads of interest within the community in time-based release management. So after introducing the projects and their problems and solutions, I will specifically look at time-based release management. I will say why it works, or why I believe it works, and I've looked at different projects, and I have evidence for that. And then I will look at some implementation, some specific implementation details that projects need to consider which are interested in moving to time-based releases. And then I will wrap up and answer questions. So the background, I started with the idea of investigating quality in free software. And free software and open source is being used everywhere. I mean, it has been so successful in the last few years. I'm sure you know that at Google. I mean, it's being used everywhere. And even though it has been so successful, and people are talking about world domination and things like that, I like to look at the glass of water, and for me, it's usually half empty. So even though it has been successful, I see there are still loads of problems. And I'm wondering, what can we as a community do about those problems? How can we still make open source even more better? And my approach is different to many people. I haven't looked at technical details, like how can you improve quality by, I don't know, regression testing or things like that. I've looked at more the process side. So how can you improve the development process? How can you, and specifically with release management, I've looked at coordination and management. It's a really interesting question. How can you, with projects, large projects, which are hundreds of people all around the world, they don't even know each other in person, how can they work together and actually produce something that doesn't only work, but is of high quality? And another question, which is gaining importance as free software and open source is being increasingly used by enterprise, by companies, how can a team of volunteers ensure that the quality will be high all the time and that there will be new releases? How can they make sure that companies feel comfortable relying on that software? It's a very big question. So I've looked at process improvement. How can you improve the development process? And when I started my PhD, I looked at different areas. I talked to various open source developers to see what kind of quality problems are there. And there are many problems. In the end, I found different problems, different areas of interest, and I decided to focus on release management because that seems to be one of the most critical areas where problems occur. The next thing, open source, free software, there are so many projects. There are large projects, very small projects. There are many projects which don't lead anywhere. You just need to look at SourceForge, which have over 100,000 projects, but you actually see that 90% of them haven't actually produced any code. And the question is, what kind of projects do you want to look at specifically? And in my initial research at the beginning, I looked at all kinds of projects to see what different problems are there. And I found that small projects face very different problems with release management to large projects. So in small projects, the problem is usually a resource problem, not having enough people, or the problem is not knowing how to make releases. Whereas in large projects, the problem is much more about coordination. How do you get with like hundreds or thousands of developers working on the same code base? How can you get those people to finish all their work at the same time and to get something out which is of high quality and which is on time? So for me, from the coordination and management perspective, this question is more interesting. So I've decided to look at large and complex projects. I'm looking at projects which are mainly voluntary. And there is a question where how do you define a volunteer? And so you could simply say someone who is not paid is a volunteer. That's one definition. But I think even paid people are often seen as voluntary because for me it's a matter of control. If the project can say, you have to work on this, then you have control over someone. Then during release preparations, you can say, well, you have to work on this, you have to work on that. But with many contributors who are paid by companies, IBM, HP, Google, they have their own interests. So as a project, you can't tell them, we need to do this. Even though they're paid to work on a project, they have their own interests. So they're voluntary. You don't have any control. And that's the main issue. I'm looking at projects which are distributed because that's where you see those big coordination problems. If you can put all the people into a room and then say, you will do this task, you will do that, it's much easier. But how do you coordinate if it's distributed? And then as I said before, I've looked at projects which are currently moving or which have moved to a time-based release management strategy. So those are the projects which I looked at. 7 projects, all of them very large, very popular. You would think of high quality and without problems, whereas in fact there are loads of problems with each of them. And what I've listed here as well is their current release strategy, their time-based release strategy, and when they decided to move to time-based releases. So what is listed here is the ideal view. So what they are trying to do. I'm not saying that they're actually doing this. So people can say we have a 6-month release cycle, but in reality it takes 12 months. But that's basically what their strategy is. So you can see that quite a few projects have a 6-month release cycle. And then there is the Linux kernel, which I classify as time-based because there is a 2-week merge window in which new features are accepted, and the rest is just for getting that code, the new code stable and getting the release out, which can take variable time, sometimes 2 months or 3 months, but still it's time-based because of that merge window. Debian is currently moving to time-based, and all of Plone is currently moving. X.org has recently moved, so you can see that. So now I will go into detail or give a brief summary of all of these projects. For each, I will show the past releases to show how often they actually make releases, how much time there is between releases, and then I will look at their past problems, solutions, and outstanding problems. So Debian, you can see that early on there were quite a few releases, 6 months, 7 months, but then things started to slow down. And the big problem really happened with 3.1, which was 35 months, it was delayed by over a year. And loads of people complained because the software was out of date. The previous release, it wouldn't install on modern hardware anymore. So what are the past problems of Debian? I think a big problem was that the whole release management wasn't organized. If you look at 3.1, there was an announcement from the release manager saying, oh, I think we should do a release in 2 months. And that's just crazy because people weren't prepared for that. And obviously, that target wasn't met. Another thing was that blockers were found very late in the release cycle. And that's, again, partly because people weren't prepared and partly because the release targets and weren't really defined very well. Because of those delays, you had out-of-date software. And because of repeated delays, the project really got a very bad image about being slow, about not being able to release. And that's a big problem because users are moving away. So what are the solutions? So in particular, during the release cycle of 4.0, which was recently released, much better release management structures got implemented. So the project moved from a single release manager to having a release manager plus assistants, and now having 2 release managers and assistants. There was better infrastructure, like a Debian release mailing list and IRC channels, so you could actually talk to the people and know what's going on. For the first time ever in Debian's history, for 4.0, a release date was set well in advance. So when 3.1 came out, the release people said, we will or we want to make a release in December 2006. So the project didn't meet that target, but still, I think the whole release process was much smoother than in previous releases. Another thing is that release updates were sent much more regularly. So people actually knew what was going on, which again wasn't the case in the past. And the project defined release targets. And they made a division between things which really had to be implemented before the release and things which were goals which were nice to have, but we wouldn't wait for them. There was also a clarification of responsibilities. In the past, it wasn't clear who was responsible for getting work done. For example, porting Debian to different architectures. If there were problems, it was usually up to the release manager to fix them or to find people to fix them. But now it's clear that the porters of that architecture are responsible. I think the biggest outstanding problem is to make a cultural shift and to show that, yes, deadlines are real, and that targets can be met, and that a project can release on time. So GCC has had a couple of releases as well. In theory, they should make a release every 6 months. In practice, it's slower than that. As you can see, there should be a release. There should have been a release at the end of the last year, and there were preparations for that, but it's still in preparation. So it's quite late. The problem in the past with GCC was a long time ago, was development was very closed. So that was in the days before the EGCSS fork. There was a very long time between releases, and there weren't any public snapshots. So when a project forked, and then took over the official development. There was loads of speed up with development, but one problem was that people were committing changes and the development tree was broken quite often, which is obviously a problem. So the solution was to that rigid and stale development, a more open development style, having a steering committee which can appoint maintainers and do various other things. And then they divided the development phase into three different stages. In the first stage, you're allowed to make major changes. In the second stage, you can still make big changes, but they are smaller. And the third stage is for bug fixing and documentation changes. And patches are actually reviewed, which means that the development tree is broken less often than it used to be. Some of the outstanding problems are that the release manager is very busy, so he hasn't been forcing the release as much as he should have been, which means for the next release, for the 2, which should have happened at the end of last year, it's still not happening, and the momentum has focused on 4.3, but the release manager really needs to start pushing for 4.2 again, and he has started doing that. Another thing is that branch criteria for making a new release might need an update because it's too strict. It's very hard to actually go into the process of making releases. Yeah?
So your point about when development picked up, changes often broke the development tree. I mean, isn't that very common for projects? I mean, Debian, previous example, was a collection of projects. But GCC is a great example of a very large project like the kernel or like Gnome or any of these things. And I see the same thing happening in the kernel tree. And is that a correct assessment? I mean, is that what you also see?
So the question is basically that changes broke the development, and that's you can find that in different projects, and it's like a normal part of development. It's true that you can find. I mean, breakage is normal. It happens from time to time. But obviously, you have to try to avoid it, especially if you want to do a time-based release. If you say we have to release on that date, well, if the development tree is broken, you can't do that. The other problem is if the development tree is broken, you can't do any testing. Obviously, development breaks sometimes, but there is a big difference between breaking sometimes and being broken all of the time, which happens in some projects. I think basically most large free software projects are pretty good. If something is broken, it gets reverted. There are some test packages like Tinderbox to make sure that things really, you can work on the tree. But I think there are loads of projects, or I hear loads of stories from commercial projects where basically the development tree is broken all the time. And it's something which needs to be avoided. But obviously sometimes it breaks, especially during stage 1, but it shouldn't be broken all the time. So going to Gnome, you can see that in the past they had some releases, and the big problem was with 2.0, which was delayed. And after 2.0, they moved to time-based releases. And Gnome is really the example of a successful time-based project. I mean, you just need to look at this. They say they will release every 6 months, and they do. And they're a volunteer project. So if you compare that to Debian, where, we're volunteers, we can't meet deadlines, we don't need to define targets. Yes, it can be done. It just needs you just need to change the whole development process and your perspective of development. So I think Gnome is a wonderful example. But again, Gnome had problems too. People don't believe it. But in the past, Gnome had very similar problems to what Debian had in the last few years. So that version 2.0, the original idea was to basically change internal interfaces, but not make many changes. The problem was it took much longer than it should have taken. People got really frustrated. And the next problem was because it took so long, developers said, well, if we ship 2.0 now, and we only changed internal interfaces, what are users going to think after such a delay? So they said, well, we obviously need to implement something which users see, and that again leads to delays. It was basically not clear what was going on, no release updates, freezes were announced, but then the release never happened. And that's very frustrating. If we are freezing, we make a release, nothing happens, and then again 2 months later, let's freeze, let's make a release, and again nothing happens. So developers really got frustrated. It was a big problem for vendors as well. They wanted to ship Gnome, but when would the next version be out? No one really knew. So what happened was loads of fragmentation. Vendors all did their own thing, which means taking development resources away from making that new release. So Gnome moved to time-based releases very successfully. They introduced very rigorous processes and policies. They had the idea of reverting. If something is not finished, well, we take it out again. And that's a really good incentive for people to actually finish. And the project really gained loads of credibility after those delays when they actually released on time. They managed to do it. And not only once, but several times. The outstanding problem, I don't know if it's a real problem, but it's sometimes raised as a concern, and it's interesting to look at it. People say that time-based releases, making a release every 6 months, as is the case in GNOME, is very good for upgrades, for updates, like incremental updates. But some people are worried that it stops innovation. People ask, well, where is GNOME 3.0 with that revolutionary change? And I think there are some counter-arguments. First of all, many of those changes which have been proposed for 3.0 have in fact been implemented already. You don't have to make a feature ready within one interval. You can simply do in a branch and take 1 year and then integrate it back. The other thing is no one really knows what GNOME 3.0 would actually be. So it seems that the release strategy is working pretty well. But there is the question of whether those frequent, regular updates stop make those innovation and big changes. I think it's possible. Just do it on a branch, and when it's ready, switch to that. So the Linux kernel is well known for having changed its release strategy completely with, oh, we don't need stable releases anymore, or we don't need a development tree. Which happened after 2.6. So here you can see the stable releases from the past, not including the new 2.6 releases. And there was really long time between the releases. So the past problem, because of the long release cycle, there was so many changes. And Linux is such a big project. I mean, you could just imagine how many changes there are. And it's really hard to test. And users, very few users actually test development versions. So what happens is that they were trying to release a new version after, I don't know, 3 years. And there were so many changes, and it was very hard to test and to get that out. Another problem was that features got out very slowly. You would implement a feature, and then you would have to wait 3 years to actually make that available to users. Again, vendors had to backport loads of features or loads of bug fixes. So there was loads of fragmentation going on. So the new release strategy has reduced that. People can actually work on the current release and together with the community. You have new versions coming out every 2 or 3 months, which means that there is a steady flow into production. So things are actually tested very quickly. If something breaks, users will see, they will report it, and it can be fixed. And again, features get out much more quickly. You implement something, and 3 months later, you can ship it to users. That's great. But there are lots of problems. There isn't really a long-term stable tree. So I know Adrian Bunk has implemented one based on 2.6.16, but it still needs to be seen how successful it will really be. And it might be a problem for companies that it's basically the effort of one person and not really something that's officially supported by everyone.
Yeah, so Debian, Ubuntu, or Red Hat, SUSE, those are the companies that provide the commercial stable version versus a open source stable version. And there were attempts to make stable versions of the kernel, like a 2.6.18.1. They'd have another number on the end for those releases too, but those really aren't the same as what the commercial vendors do. People are really paying attention to what the commercial vendors are doing.
That's right. So there were two issues. The first is that the long-term stable releases are really provided by vendors, by a Linux distribution. And yes, that's how things work. And the other point was that there are stable updates to releases, but that's really only for the current stable and maybe for the last one, but they are not supported a long time. Yes, so it's true that the model is basically that the project ships something and then it's up to the vendors to make a long-term stable product out of it. The question is whether that's the ideal solution, because again, there is some fragmentation. On the other hand, there is no agreement. Let's say we make a stable release. Should we go with 2.6.18, 2.6.16? Because vendors have different schedules, different release cycles. There isn't really agreement. So maybe that's just the way it is and has to be. But it's still an interesting question whether we could do something about it. And there is the more fundamental question whether, so who are the users of the Linux kernel, of like the kernel.org kernel? Are the users people who actually run the kernel, like end users, or are the users or customers the vendor? And at the moment, it's mostly focused for vendors. And it's a question whether that's a good thing, because you might lose feedback from users. It always has to go through the vendor, and that slows things down. So it's a question whether it's a good thing. But yes, that's the way it currently works. The other problem with that fast development, so you get releases more quickly, features get out, but there are so many changes and there are so many regressions. So there are lots of people who are quite unhappy with that. But again, yes, they can use and probably should use a vendor kernel. So OpenOffice is an interesting example because it's a very commercial open source project. It has some community involvement nowadays, but it's still very much led and financed by Sun. They pay the release manager, and the release cycle used to be 18 months because of the commercial product StarOffice. And many open source vendors like Novell weren't very happy with that. They wanted to see more frequent releases. And in the end, the project decided to move to more frequent releases, making a release every 3 months. So because of that long release cycle, very little testing occurred. Many changes accumulated. You can see there are many very similar problems in those projects. And features got in very late because it was such a long time, and you realized, oh, we need that feature in order to, I don't know, react to Microsoft Word or some other development. And again, the problem with vendors, well, what kind of version should we ship? Should we wait? When is it going to be out? And there was a major delay with 2.0. Which should have been 18 months, but it was actually 26. So that was a major delay. So in the end, the project moved to 3-monthly releases, which means that there was a much better feedback loop with users. It also means that features actually get out, which increase developer motivation. And the better planning, every 3 months there's a release, allowed vendors to be involved much more in the development. And another thing which Sun has done is to make the release process more transparent, so other people can actually get involved. One of the big problems is that the project found that 3 months is actually too quick for them. They found that it's really hard to do quality assurance if you have a release every 3 months. And they found that some of the users didn't actually want to have new releases with new features every 3 months. So they're currently moving to a new schedule with major releases every 6 months. And in between, every 3 months, they have smaller updates with bug fixes. Plone, the history here is it's still very young. You can see with 2.1 there was a major delay, and that really prompted a change in the release policy. So releases, in particular 2.1, took a long time to get out. Because of those many changes, users faced upgrade problems. And many Plone developers are actually working as web developers. And for them, it was very hard to make a decision, should we use the current version of Plone, or should I wait for the next version? Is it going to be ready for my project? So the project decided to move to time-based releases, but I really don't know how well it's working. They have only decided very recently, and so far there have been delays. So I don't know whether they can pull it off. But what they have managed so far is to implement much better development structures. It's a much more disciplined development process nowadays, which means that they can release on time. And we go back, you can see that 2.5 was released 9 months after the previous release. So obviously there were improvements. And they also say that those deadlines have motivated developers to actually work on the code and to finish their features. So X.org is another example which basically forked from X386, and they moved to time-based releases with their 7.0 release. Again, 6 months. For the first release, they managed to do it in 5, but then there was a delay for the next one, 9 months. So X3 was a fork of X3. X.org was a fork of X386, which had loads of problems. There were very infrequent updates. The development process was just very rigid. You couldn't do any major innovation. And there wasn't any plan. Another problem is, or was, that the code base is huge and it's monolithic. It's like one big thing, and it's a very complicated build system. So what they have decided to do is to split that up and make a modular system, and also to change the build system. What that split into the modular system allowed the project to do is to have 2 different release mechanisms. So those individual projects can make their own releases whenever they want to, and then there is the official, a roll-up release of all those individual components into an official X.org release. And that's quite interesting. And if you think about it, you see, oh, that's actually how lots of projects work. Like Gnome, it's not one project. There are so many different applications. Debian, there are so many different packages. You can see that in every large project, that really there are subsystems or different components. And ideally, if you can get them to release independently and then have a big release for everything. And it's good because that's a fallback mechanism. If a single component is not ready, you can usually simply take the previous one. The interfaces in X.org are pretty stable, so you can actually do that. And it's really good, because you don't need to wait for all those components to be ready. Outstanding problem, they need to clarify the interfaces so they can update their drivers more often. So those are the 7 projects. And I think what you have seen is there are very similar problems. Delays, loads of development occurring, accumulating, making it hard to test, vendors not being able to work on the main development because it's so unpredictable. Very similar problems. And those delays lead to loads of problems. And I think the fundamental problem is that the way open source works is simply very hard to integrate with release management. Because the way it works is that people do their own work very independently. There are hundreds of people just doing whatever they're interested in, and some of them might be just nearing the completion of a feature, whereas some of them might just be beginning. And that's a problem if you want to do a release, because if you just say, today, let's release, then you see, well, some projects are finished, but some of them are very unstable. And that's basically what happened in those projects. Releases were announced out of the blue. There was no plan. It was simply the release manager, well, I think it's time to make another release. Let's do it. And then people said, well, but I'm not ready. I need another 5 months. And there were delays. Everyone tried to get their feature in. Because of those delays, people weren't sure when the next release would be. It might be 3 years away. So I really need to get my feature in now. You have seen that in Debian. You've seen that in the Linux kernel. You can see that everywhere. So what's the solution for that problem? How do you get all of those individual developers to be ready at the same time automatically? And the answer is time-based releases. Instead of saying we will release when those features have been implemented or when everything is ready, I mean, that just doesn't work if you have hundreds of people with different features they want to get in. You just need, so instead of saying we release when those features are ready, you simply say we release on this particular date. Everything that is finished 2 months before that date will be included. Everything else, you have to wait for the next release. and that basically allows people to work on their own features very independently. And then if they are ready, they can simply come back, integrate it in time. If they're not ready, they know the next release is only going to be so far away. So there are two misconceptions about time-based releases. First of all, time-based releases doesn't mean you have to release on that date no matter what. I mean, if the development is broken, if there are security issues, please wait and fix those issues. It's just about what is your guideline for making releases. The other thing is you still should plan for features. Planning for features is good because it means more work gets done. If you just say, well, there will be a release, so I can sit back and relax, nothing will happen. So you should plan for features, but just don't delay the release if those features are not ready. So what kind of conditions are necessary for a project to implement time-based releases? Time-based releases, I think it's great, but it's definitely not for every project. In fact, it's only for a minority of projects. I think, for example, it only works for large projects. And the reason is the first point here. You really need enough work during one interval. If you have a very small project and nothing gets done in 6 months, well, why should you make a release every 6 months? There is no reason. But if you have a large project with hundreds of people, there is so much stuff going on, so many new features, so many bug fixes, that yes, it makes sense to do regular releases. Another thing is distribution has to be cheap. Because if you release regular releases, you need to get them to users. So if you would rely on publishing CDs in a shop, you couldn't do a release every 6 months. Fortunately, free software, we have the internet, distribution is cheap. That's not a problem. The other thing is that releases don't require any specific functionality, which again is true in most free software projects. But it can be a problem in commercial open source where you actually promise the customer that that release will have those features. And the last point is that the project has to be modular. And that's because if everything is tied together, then if you have one problem, you can't release anything. But if it's modular, you can simply ignore some things which are not ready on that release date, or you can revert them back. So basically, my argument of why time-based releases work is that they act as a coordination mechanism. they have two things which act as coordination mechanisms: regularity and the use of a schedule. So regularity has three positive aspects. It creates a reference point. So essentially, what I said before is you have all those developers doing their own work very independently without necessarily having to talk with each other. And that's good. But there are always changes which are related to your changes. So you need to go back from time to time and say, OK, so here are the changes I made, what's going on in the rest of the project. You need to know what's going on. And having a regular releases creates that reference point. So you create a reference point, everyone knows that's the official tree, that's where we are. And then everyone again goes off, does their own little thing. And then 6 months or 9 months or whatever later, they come back and say, well, what has happened? The other thing is that regularity creates discipline and self-restraint. As I said before, because of those long release cycles and those delays, people really wanted to get their features in. If I don't get it in now, it might be 3 years. I need to get it in. And that causes delays. But if you have a regular release cycle, people know there will be a release again. If I don't make this one, it's only going to be 6, 9, 12 months, whatever. Then people can say, well, OK, I will really get it done properly. I will test it and then just make it for the next release. And the next thing, the last thing, is familiarity. One problem with doing releases only every 3 years is that people just aren't familiar with it. It's not part of the development process. It's something you do sometimes you don't have experience with, maybe you don't like it. But if you do it every 6 months, it's just a standard practice, like brushing your teeth before going to sleep. You simply integrate it, it's normal, and you get experience with it. The other thing is that the use of a schedule, as I said before, allows people to do their work independently. So what happened before, when no one really knew what was going on, there are always dependencies. A translator can only do their work when the documentation is done. You can only write an application when the libraries are stable, when interfaces are stable. So what happened when no one knew what was going on is that people always had to talk to each other. And they had to talk to the release manager. So how long is it going to take? When can I start? And that's coordination. And that's expensive on the internet. But what the schedule allows you to do, it allows you to put that information into the schedule, give people their schedule, they can take it and work independently and know, oh, on this date I have to be done. And ideally, they will come back on this date and it's done. And then the next person can simply do their work. So it reduces that active coordination, which is expensive. So what are the incentives for time-based releases? And again, that's beautiful because it's good for everyone. I've listed 4 different stakeholders. There are organizations like Google. If you have to upgrade 10,000 machines, you really need to know, you need to plan, you need to know when the release will be out. And time-based releases gives that predictability. For users, it's great because they get periodical fixes. They don't have to wait 3 years for their issue to be fixed. Ideally, they will get it after 6 months. And it means that the upgrades are much easier. You don't have that big bang release which changes everything. You just have smooth upgrades every once in a while. For developers, it's good because they know when they have to get the code in order to make the release. And the other thing is that their work actually gets to people. They don't have to wait 3 years. And for vendors, it's good because they can plan and they can actually work with the community. They can work on one code base instead of everyone doing their own thing. So some specific advantages for developers, and I think those are only some of them. So it creates discipline, but not discipline in like that negative bureaucratic way that, oh God, I have to fill out 10 pages of papers before I can do anything. It just makes the whole development process more structured, and people know what's going on. It allows better planning. You know when you have to get your features in. It creates better feedback because your users, you have a much tighter feedback loop with your users. And that makes users happy. They see, oh yes, we're getting fixes. So they might send you really good bug reports. And the other thing is that it really increases developer motivation. Yes, you get your code out. If you look at the sum of code, and if a student is involved in a project which releases only 3 years, and they make something this summer, they contributed, and then they can only tell their friends after 3 years, oh, and here is the CD, and here is my contribution. But with regular releases, they can do it in 3 or 6 months and say, here's what I did. It's cool. I want to do it again. So if projects want to move to time-based releases, you need to decide what kind of release interval is good for me. Should I release every 6 months, every 3 months, every 9 months, every year? And there are a couple of things which should be considered. One of them is regularity and predictability. If you look at time-based, the definition, you don't have to have the same interval all the time. You could say, now we make a release in 6 months, and then we make a release in 9 months, and then maybe in 3 months. But I think it's very good to have that regularity. Then there are user requirements, and that might depend on your software. Is it mostly for servers? Is it mostly for desktop users? On servers, you might have a slower release cycle than desktop software, or maybe not. There are some commercial interests which are really important. Like one issue when OpenOffice moved to 3 months was book authors. They want to write books about OpenOffice, but if there is a new release every 3 months, your book will be out of date before it actually gets to the market. And book authors are actually really important because they build bridges between the user community and the development community. And there are many commercial interests which really benefit your development and which you should take into consideration. Another thing is that there are various cost factors with making releases. Releases cost time. They take resources. For example, you need to support older releases. So if you have frequent releases, you have more older releases which you may have to support. I know open source projects are pretty bad with doing that. And more frequent releases probably make the situation even worse. Then you have some fixed costs. You need to test your software. You need to actually prepare it. You need to write announcements and things like that. There might be confusion among users. Oh, I just upgraded to that new version, but I see that I went to the website and I saw that there is a new version out already. So it takes a while to get into a distribution. So by the time it reaches users, there might be a new upstream release already. It might cause fragmentation of users. If everyone's using the same thing, it's really easy to track bugs. But if people are using many different versions, it's much harder. And there are upgrade costs as well. Upgrading, you can't upgrade every day. It takes time. You have to download it, and you have to look at it if something breaks. And then there are really important network effects, working with other projects. So one reason why SOAP moved to 6-month releases or are trying to, Plone, sorry, the Plone project. One reason was because they want to have the same release cycle as SOAP. So they built upon SOAP. And they said, well, if we have the same release cycle, we can use all of those new features from SOAP in Plone. And that's really interesting. It's a good point. There are also many dangers, because if SOAP is delayed and Plone uses all of those new features, you can't ship the new version of Plone either. So that's something you have to consider. The other thing are distributions. Open source projects really benefit from being in a distro because that's what users use. And if you have a similar release cycle to distro, it means that your latest software gets out to users much more quickly. So when I showed the picture before about the projects and their release cycles, you saw that many of them are doing 6 months. And I think there's a good reason for that. First of all, it's a reason of regularity. If you have 7 months, what happens is that your schedule always slips on the year. Sometimes you might have a release during Christmas, and it's a bad thing because your people aren't there to actually do the work. And having 6 months means it's always the same. It's always, I don't know, March and September. You just know it's always going to be the same, and it makes life so much simpler. The other thing is having all those projects having the same release cycle, so 6 months, promotes those network effects, which I mentioned. So the question is, well, we are a large project. How do I actually move to a new release strategy? It's not easy to do that. It's very hard. And as you can see in the projects which I discussed, not all of them are successful with the implementation. They're still working on it. So there must be really good incentives to actually change. You must have real problems with your current release strategy. And the projects which I looked at all had those problems. And then it's also a matter of control and trust. In some projects, it's basically the leader says, we will do this and it's okay, it will be done. But there are other projects where you need agreement from many people to make those changes. And you need to really introduce policies. Like I said before, you need to make sure that the development is truly stable, because if it's not stable, you can't make time-based releases. You can implement structures or policies to make your development more structured. Like some projects have feature proposals where before committing a feature, you have to write it up and have a plan. GCC does that, Plone does that, a number of projects do that. And it's not bureaucratic. It's actually, many people see it as good, because you know what's going to happen, and you have some kind of target. And yeah, defining milestones and deadlines is a good thing. The other thing is coordination and collaboration. You really need to talk about the release. Not sending release updates is really horrible. You need to send updates. You need to be available as release manager. And that's the last point, that you really need to actively coordinate as a release manager. You can't just say, oh, let's publish that schedule and we will assume everyone will follow it and will just do their work. You still need to actively tell people, now the deadline is approaching, please be ready. So coming to the end, what are the conclusions of that work? So I think what I've shown is that some of those projects have reacted to those problems and to other changes. So I think what happens in many projects is they start off very small, and if you're very small, if you have 2 people, you don't need a big release process. You just talk to each other and make the release. But if you suddenly have 1,000 of people, the same thing doesn't work. You need a different release strategy. And I think it's sort of natural as projects become large to move to time-based releases. So I think they have adapted to their growth. And the other thing is that they might have adapted to their users, because now open source is used much more by companies which need that predictability. So I think time-based releases are a good solution to adapt to growth and those users. As I argued, I believe that time-based releases work because they rely on 2 coordination mechanisms which make life so much easier than having to actively coordinate everything. As I said, regularity and the use of schedules. And as I said initially, I defined volunteers as whether you have control over them. And that's important because in a volunteer project, you can't tell people what to do. So you can't be sure that any feature will actually be done on time. The only thing you can do is you can set a deadline, a time, a target date, and include everything that's ready. So what I have shown in that research is that using time rather than features is a really good way to coordinate volunteer projects in which you have little control. And the next question is, well, what kind of other volunteer projects are there, and do similar things apply to them? I strongly believe that free software and open source, what we are learning here about the methodology, about how to work together, how to collaborate over the internet with volunteers, is something which we will see in many other different areas as well. I mean, there are people sharing cooking recipes and stuff like that. But there are lots of people who want to modify their cars, and the only reason they can't do that as much as we can do with free software is because our production machinery is like a PC. It's very cheap, but with building a car, it's really expensive. You can't just do that at home. But I think in the future, that's going to be much more easily available and much more cheaper. So I think we will see much more collaboration over the internet, and I think what we're learning here is really important for them. And release management, time-based releases, is really important. So for people who are interested, I have my whole PhD thesis on the web. And I recently started blogging about some of the results, so you don't have to read the whole 200 pages. So that's available on my website. I can also be contacted, and obviously now I'm happy to answer any questions you might have. Yeah.
So, again, you're using Debian as an example, and a lot of the problems I saw that release slipping was small but very important segments of the project were delayed, and I was just wondering if that's a common, if that's common to other projects where there's a very small but extremely important part of the project is blocking the rest of the release, and what kind of things maybe can be done about that sort of situation.
So the question is, in Debian, in the last release, it seemed that there were very small but very important areas that were blocking the release, and whether that's the same in other projects. I think it does happen, but I don't think it's such a big problem in other projects. So if you look at GCC, well, maybe yes, it depends on how you see it. On GCC, the problem is that there are a number of there aren't many, but there are a number of regressions, and basically no one does anything about them. I guess the difference with GCC is that it's not so clear who should fix those bugs, whereas in Debian, it was very clear, I think, who was responsible for those areas or that work that didn't get done. So I think that Debian, even though it defined targets, it tried to look at the blockers. I think that the release team wasn't strong enough with following up with those people to make sure that those blockers actually get resolved. So for me, it was pretty clear that we would have to wait for the kernel, but no one did anything about it. I think you could really see it coming. So I think that's something, an example of where the release team has to be more active, where you really need to tell people you have to be done. Anything else? Okay, thanks for coming. And if you do have any questions, I'll be around today, and you can email me. My email address is on my website. Thanks for coming.